this 3-beard? Yeah, Hannah. We melted down. Testing, testing. Can you hear me in the microphone? No. Turn mic on. And then if I speak into it, there it is. Testing, testing. All right, everybody, let's get started. Can you hear me in the microphone? Can you hear me? To put it. I have to speak directly into it. Maybe I'll just do that. I'll just hold it. That works. Hi, everybody. Hi. I'm Ralph with no beard. My name's Ralph Bean. I work in P&T DevOps now on the productization pipeline used for all Red Hat products. I used to work on the Fedora engineering team for the last 4 years, working on the tool chain there, all the tools that go into making Fedora something that is able to be shipped and actually used by users there. So the talk today is about Factory 2.0, which is well, we'll get into exactly what it is. Uh-oh. I want to start with some backstory, some context. Can I have people in the room raise your hands if you've ever heard of the Eternal September, or the September that never ended? So it's a minority of hands, I think. So this is educational backstory, hacker lore that you get to learn today. Back in the day, when the internet was first becoming a thing, every September there was this tradition that happened. There were a very small number of users on the internet that had their own culture, their own way of interacting with each other. And every September, a new influx of university students would go to university, get access to the internet for the first time, and there was this process of about a month in September where the existing internet users would teach the new internet users, the new students, how to behave on Usenet. And then after that, they were acculturated and things were fine. Well, in 1993, that's when AOL Online, the internet service provider, first provided access to users to Usenet, and the influx of new people coming to Usenet was so great that it was never possible for the old guard to kind of keep up with educating new people on how you should behave on the internet. And so it's called retroactively the September that never ended, or the Eternal September. So that's a thing that happened, and now you know. What that means for us, I think it's useful to draw an analogy between that point in time and what's happening now in open source ecosystems, in that it's changed dramatically from when Red Hat first started as a company, from when Linux distributions were the primary place to go to try and get your software to be something that people would use and people would use as a platform to integrate on top of. This is a graph showing the number of packages in different language ecosystems, Ruby Gems, PyPI, and NPM, or Node.js. If you can't see the absolute value, the number of NPM JS packages here in like halfway through 2016 is crossing the 300,000 mark. We have 17,000 packages in Fedora right now, which is more than we actually want. It's more than we can handle or maintain. If you think that we're going to be able to somehow keep up with 300,000 packages just for npm.js, that's a losing proposition. So the point of the analogy with the eternal September is that things like the rise of GitHub and other practices in open source communities just mean that the times have changed, and the whole model of how we've built Linux distributions was arranged around a time that doesn't correspond with how things are now. Right? It's a different era. That graph and things that have gone on have had consequent changes in the way that application developers build their apps. Whereas they used to look to the Linux distribution as a platform that was common, something they could build their application on and pin their dependencies against that. Today people do things like this. Pip freeze is a command for Python that takes all of the specific versions of all of your dependencies in your Python virtual environment, freezes the version and writes it out. Anyone who wants to run your app has to use exactly whatever you had installed at that particular time. That works great for apps to be able to isolate themselves from all the changing things in the ecosystem around them, but it works terribly for a Linux distribution where we're providing a certain set of packages which almost certainly don't correspond with whatever the developer had installed at that particular time. So in my opinion, modularity, the whole modularity effort is our attempt to address that situation and make the Linux distribution compatible with the new way that apps are developed and cooperated around. And our entire toolchain is built on a way of building the Linux distribution that isn't compatible with that. So we have to think about the tools too, which is what we get to here. So Factory 2.0, if you've seen other talks, it's not a lot of things. It's not what you might think it is. There's no single Git repo where you can go and check out the Factory 2.0 code. It's not a project in that sense. It's more of an initiative of looking at our toolchain as a whole and trying to make changes to it across the board. You can read our design documents for more on that. Today, I'm not going to cover all of the things like I've tried to in the past because it remains too high level. And instead, I'm going to try and focus in on just 3 of them. I want to talk about measurements, continuous integration, and the modularity effort specifically. Oh, my diagrams are going to be weird at this aspect ratio. We'll roll with it. This is a depiction of the existing pipeline. There really is nothing to the right of the diagram. In this case, it just kind of ends with the release checklist. So this looks nice and simple. If you've ever developed on Fedora or for RHEL or for CentOS, you know that there's dist-git. Things then get built in Koji and Brew. They go through a compose process and then a release checklist to get out the door. It's very, very simple. Right? But if you've ever used it, you know that there's actually a lot more things going on around that, and a lot of things about it that are more painful than just moving right through. But for now, let's just pretend that things are like this because we're going to elaborate on this basic framework of how things get through and show where there's problems and talk about changes to that. To start with on measurements, this is a screenshot of a dashboard that we've set up internally. We're not doing the same work for RHEL because we'd really have to duplicate, we're not doing the same work for Fedora. We're just doing it for the internal pipeline because it's not as easy to duplicate across the two. But one of our mandates is to measure things that are a problem with the current existing pipeline to determine how bad things are so that when we make a change, we can be sure that we're either improving the problem or maybe our change had no effect. So here, I'll explain these two. This is titled the RPM diff flag. There's a tool called RPM diff that we want to run in response to every new RPM that's being built in the internal pipeline. And on average, if you pick a day, this day, on average, there was 100 hours of lag in between when something was built and when RPM diff was run on it. Having RPM diff results is actually a really useful thing. That should be a small number. That should be 0, right? 0 hours or 1 hour at most on average between that, but we have 100 hours today. And then here, this graph is titled the RPM signing lag. When things enter a certain state in our release process, we want them to be signed with a GPG key that signifies that they're gold, they're good, and coming from Red Hat. That currently is a manual process. And in this graph, it's much, much worse. Between when things are allowed to be signed and when they actually get signed, on this date, the average was 800 hours between those two things. That's a huge amount of wasted time just waiting for something to happen, and that's unacceptable. The point of this is to say that both of these are things that we're intending to either solve by automation or by shuffling things around in the pipeline so that things can just happen when they need to happen. We would like both of these graphs to go down to 0, but the point is that we're gathering metrics ahead of time to be able to see what the problem is. That that whole project of doing measurements is much more complicated than we originally thought it was going to be. I think just gathering metrics seems like it's simple. But the problem is that anything that's a useful metric that gives us some real insight involves collecting information from multiple systems in the pipeline and correlating it together. As an example of one of our more complicated ones, we have a mandate to make building content into containers as easy and as painless and as quick as possible. And so a metric to measure that would be anytime you make a change, say in Fedora, to an RPM package, to a spec file, that then has to get built as an RPM, and once it gets built as an RPM, it can be included in a container. And so if you want to figure out how fast that is, measure the difference in time between when a container gets built and when was the last commit to any spec file that was included in it. It's hard to get that information in the first place. It's possible. We have code to do it now. But it gets really tricky, because what about if there's one RPM that, say, hasn't been updated in 3 years because it's just super stable and it's not going anywhere? Well, actually, then that time between the commit and the latest container build is 3 years, and it throws our average off. So thinking about what the metric means and how to produce it in a way that will actually be useful is just harder than we thought. That's all to say on that. Many more metrics to come on that front. So to change topics, continuous integration. This is a depiction of how continuous integration looks today, both in Fedora and in the internal pipelines. This is our friend diagram at the bottom, the existing build to release pipeline. And basically all that we have is that each of those systems announces activity about new content that's either been changed or built or composed to a message bus. And then we have, I have this cloud up here for CI infrastructure. And excuse me, CI is in quotes. For a reason. Can anyone tell me what is wrong with this diagram? Pingu. The CI is after the change. That's one way. That's one thing to think about it being wrong. Any others?
Also, they can go around the CI.
That's also true. Yeah. So another way to say that is that there's no gating, right? The CI doesn't actually impose any restrictions back on the pipeline. Yeah, the arrow from the CI doesn't go down far enough. Yes. That also, although, sure, yeah, that is a problem, but I don't know if the diagram metaphor fits, but yes, exactly. Moving on.
I do like how the message bus looks like a hot dog.
It sure does. It's a beefy miracle. So the first step that is on our road to solving this problem is we want to introduce this service. We're actually co-opting it from the Fedora infrastructure called ResultsDB. It's how you start to get, I think it was Adam that said it, that the arrow from CI doesn't go back down far enough. It's the way that we begin to get that arrow to go down. Notice how the CI infrastructure is in this big cloudy shape, and that is for a reason, in that our existing, what we have been calling our CI infrastructure internally, is a whole set of Jenkins masters and Jenkins slaves that are available for various teams to run whatever kind of tests in them that they want. And that flexibility is good in that it allows test teams to move at their own pace, make their own decisions, and do their own things. But it's bad from a release point of view, from a build and release point of view, from the point of view of my group of DevOps, because we have no way to consistently query for the results of that information to make decisions in the build to release pipeline, to make decisions about whether a branch should be accepted or not, to make decisions about whether or not something should be gated or not. So the first step is, again, collecting those results in a homogeneous fashion behind a homogeneous API so we can make decisions. Some more detail on exactly how we're getting that data, because it's not quite so simple, right? It's this big fuzzy cloud of many, many Jenkins masters. This is to show where we're at right now. We have this project called we're calling it the CI metrics data feed coming out of platform engineering. That feed was originally established to go through the message bus and populate an ELK instance for reporting on metrics about what kind of tests we're running and how frequently we're doing it, not to make decisions about automation. But we are working with that group, and or we're collaborating to use a more negative term. We're co-opting their data feed, taking it and using the exact same feed to populate ResultsDB using a microservice we've put in front of it called ResultsDB Updater. And this is done and is in production right now. The better plan that is coming down the road, and we have agreement with the groups, but it's a matter of getting all the pieces lined up to get there, is there's a separate initiative called ShipShift that's about taking all of the artifacts from these Jenkins instances and making sure that they get archived to cold storage so they can be saved forever and looked at. They want to publish information to the message bus also to have workers pull those artifacts out. We want to listen to that feed and use it for the same purpose to store up this metadata in ResultsDB so we can make automation decisions based on that data coming out the bottom. So the key difference is that one is only for one group inside Red Hat, the platform on the left. The other will encompass all the various business units, all the different products in Red Hat, so we can have a more comprehensive solution at that point in time. So here, expanding the picture a little bit more, this is putting ResultsDB to use, right? Once we have that populated with information, there are multiple points in the pipeline where we want to query that data to make a decision about whether to move something forwards either automatically or to gate something and not allow it forwards. Starting at the far end, in the release checklist, like Bodhi, the Bodhi updates process in Fedora or the errata tool internally, today, the way this works internally is that when the CI infrastructure completes its tests, engineers go and look at the results visually with their eyes to understand whether something worked or not, and then they go manually to the release checklist tool and check off and say QE tests passed automatically. We would like instead this tool to automatically display the information from ResultsDB about whether tests passed or failed, and then depending on rules that are defined on a per product basis, and I'll get to that in a minute about how we define those different rules, either automatically progress the advisory or simply allow it to move forwards upon some sort of manual click. Here we have determined that we have a need for an automatic rebuild service, especially with the advent of containers. We're going to have many more different kinds of combinations of content. The process of making a patch to something like glibc and then going through a 3-day manual effort to rebuild the world is not acceptable anymore, so we need automation to drive that. That sort of service needs a way to consult the results of QE output by looking at ResultsDB to know whether to progress to subsequent tiers or not. And lastly, and this is what Pingu was commenting on early, distgit itself, the real dream for CI is that any change that gets proposed in distgit before it even gets merged is something that needs consultation with QE feedback, with the results from CI runs, which is we want to gate right here before we get any problems in the pipeline at all. But by using ResultsDB like this, we can use the same runs from CI. We can use the same set of test cases to drive the decisions made at each of these different places. In the best case, all the problems get caught here and nothing happens really in the rest of the pipeline. But reusing it, I think, is important for a redundancy and a resilience perspective. So now we have a complication. In Fedora, we do not have an answer to this solution, but we do have an answer to it internally. Baked into the errata tool and some of the tools that form a constellation around the errata tool, like RPMDiff and others, there is functionality for waivers, meaning if a result coming back from automated tests is wrong, a human can say, this doesn't really matter, just waive it, it's fine, it can move through. In Fedora, we have integration with our updates tool with our test execution, but if the tests are wrong and something's being blocked and it should progress anyways, the solution is just to change the requirements on your update so it can proceed through, which doesn't make sense, right? So having something abstract like this, okay, I should explain what this is. WaiverDB is a new service that we have a requirements document for in process, but we need to actually write and implement that will house an abstracted version of the logic around waivers from our existing tools, which will then repurpose and use throughout the pipeline. So to show here, the results that go into ResultsDB are immutable and come from automated test runs, and we don't want humans to modify any of the results in ResultsDB, so they give an accurate reflection of what happened in the test automation. WaiverDB, however, would be human input only, where you could waive an individual result in a particular decision context, say waive it for a distgit change but not for the release checklist, and furthermore specify auto waivers. So if you know a certain kind of test case is just perpetually broken, you can waive it for these cases but not some other one. That's complicated logic that we don't want to have to duplicate in all our other tools, so abstracting it out into its own service makes sense. Now, here in the middle, I have this note about tools cross-reference entries in these services to make decisions, and see how there's duplicated lines going from every service to both of those services. That, to me, is a key that we need to introduce yet another service here. We're working on a name for it. We're currently calling it the policy engine, but it would be the tool that would understand exactly how to cross-reference entries from those two services and make decisions about what should be done. for instance, each of these services is going to ask a different kind of question to the policy engine. Given a proposed patch in dist-git, we want to know, is this good to merge or not? In the policy engine, we would need to define ahead of time a policy for this kind of product group or for this kind of subsystem. These are the conditions that need to be met for something to be good to automatically merge or not. And if they're met or not, then we proceed. It's a different set of conditions that may need to be met for the automatic rebuild service and a different set of conditions, again, for something to be good or not to release. So abstracting that in policy engine is the current plan. And this last slide on CI, just to get back again to Pingu's point about blocking branches before they actually get merged, the key will be to stand up a pull request interface on top of dist-git, which I think is going to take different forms in the two environments that we're looking at. In Fedora, almost certainly it will be Pagger. I have the pronunciation right? Yeah, Pagger. Just because it's the people in the Fedora community already know it and love it, but I have a hunch that deploying it internally is not going to be quite as simple or quite as palatable to people around. So there's already familiarity internally with both GitLab and Gerrit, so it'll be a question of deciding which of those two interfaces is the preferred one and standing it up in much the same way. A thing that is interesting about our infrastructure is that we have a lot of implicitly defined workflows that go between systems. So currently our again, what we have been calling our CI infrastructure, the both Taskatron and Fedora and Jenkins internally know how to implicitly respond to new artifacts that are available for testing. So when Koji finishes building something, it announces it on the message bus, and CI picks off and takes off and does its thing. CI systems that work quite well in other environments for other organizations tend to, instead of being implicitly defined like this, are explicitly defined. So if you see, like, for instance, the work that Ari was demoing earlier with Jenkins pipelines, or if you see anyone, like in upstream OpenStack where they're using Zool, in both of those cases, this circuit is defined in some sort of file. Like, first there's the build step, and then there's the test step, and then there's the decision step. In Jenkins land with Ansible and Zool, it's much the same way. But we already have a wealth of tools in both environments that have this implicit step, so we're going to have to think creatively about how we write the trigger in the pull request interface to know how to kick off the first step in the process and then wait for the appropriate conditions to be met with some sort of timeout in order to proceed. That's just to point out that I don't think we're going to be able to copy any sort of pre-existing solution to be able to graft this onto our infrastructure that we have, and replacing wholesale is too costly in my opinion. Okay, new topic, building modules. This is for Fedora 26 and going forwards. My team has been working on that CI front. We're also extending effort towards the modularity project in Fedora. This is a depiction roughly of how the module build service, which is a new tool that we've written with the modularity group, fits alongside other pieces in the pipeline. The main point is to show that the actual work of building the RPMs that become a part of a module is actually done by Koji or Brew, the build system that we've been using for an eternity now. But the module build service serves as a sort of workflow orchestration layer on top of Koji and Brew. To describe what it needs to do, I'll move to the next slide. The way that things are built today is that we have a tag for a particular release of the distro, the F25 tag. And as you build a particular RPM, the build route for that build, the RPMs that need to be available for to meet the requirements of its build requires, come from one repo or come from one tag. And once the build is completed, it is added back into that tag in most cases, or sometimes it's added to a candidate tag and ultimately promoted to be in that tag. A consequence of this is that tag is a moving target, and you can't just ask, like, you can't just say, I depend on F25, which I depend on F25 at a particular day or a particular moment in time to know what the contents of that build route are. Build routes with modules involve something different. Those tags, those mega tags like F25 are something that are currently created by RCM by hand. At the time when we declare we're going to do a new branch for a new release, new tags are created and populated with content from the previous release, and things are set into motion. Modules get their own build routes and their own tags for each build of the module that comes along, which means that that's not something that we can ask RCM to do. We can't ask a human to do that every time we want to do a new build of a module to create a new tag for us by hand. So that module build service, like I was talking about being an orchestration layer around Koji and Brew, is something that automates the process of creating those tags and preparing the build routes in a way that's sensible for the build of that particular module. This is a depiction of the container architecture that the Modularity team has come up with, and the point is to show how different modules map to different layers in containers as we intend to build them and ship them. The base runtime module corresponds most closely with the base images that we've been building today for an F25 release or F26. But that each individual module that we produce, the intent is to build layer 2 images that correspond with install profiles that get defined by those modules. So you may have one module that defines 2 different ways that it could be built into a container, but those containers aren't the end product and ready to be used. The particular use cases for them, the configuration and the running of an application happen at a last step, so we can special purpose them for different deployments and different needs, but that the software from the module is provided as a reusable layer in the middle. So let's talk about dist-git. This is work that we've been discussing for a while, and the plan is to start it shortly after DevConf. The F26 freeze comes at the end of February. We'll be deploying the module build service for that. Coming after that deployment is where I think things get really interesting and things really start to change for the distribution as a whole. This is what branching looks like for any particular component in Fedora today. Say it's Python requests. We have a branch for each release of the distro, including master, which maps to rawhide. The way we want to change that is actually stop producing new branches that correspond with the release of the distro that's coming up, but to instead create branches that correspond with a release of the upstream package or the upstream project to which a component relates. And this has some pretty interesting implications, both challenges and benefits that come to the maintenance of software in the distribution. Just for comparison, we intend to do the same thing with branches for internal components, whereas today we would have branches for RHEL and layered products named as such. That has a multiplicative effect where every combination of things we want to produce creates a new branch that has a new maintenance overhead for the entirety of the lifetime of the product. The idea here is that by creating branches that correspond with upstream releases, we'll have a much more maintainable way to support backporting security fixes onto those branches that isn't product specific and doesn't grow with the scale of ways that we want to end up delivering that component. So the way that we intend for these to get used, right, is by, here's showing on the left, 2 RPMs, Python Django and Python requests, having a master branch, and then having branches that correspond with upstream releases of those projects. And on the right, having a module that corresponds with a whole Django stack that would need to pull in the RPM for Django, but also all of the dependencies that go into supporting that release of Django and making it something that's usable. We could have, let's say, like a branch 1.9 of this Django module that declares a dependency on the stream, declares a dependency on the stream, a dependency on the branch 1.9 of the Django RPM, and then also declares a dependency on the 2.12 branch of Python requests. And so long as 2.12 has lots of sub-releases, right, 2.12.4 and 2.12.5, the point is that all of those, depending on the properties that are defined associated with that branch, could carry those .z releases in that branch, and that module would consume them, but not API breaking changes that come with a 2.13 release of Python requests. But a module, or anything we have that is like an application, that would need to sit on top of the base runtime can pick and choose the support streams of its components that need to go into it to fit its own purposes, instead of having to choose from what's already available in the whole distro. So there's lots to think about with a new branching structure. For one, are we going to have an F27 branch at all of any components when we get there? We're not making this change for F26 itself, but for F27, will we even have one? And my thought is that no, there won't be a point to have one unless there's whole subsections of Fedora that aren't ready to make a jump to a new upstream mapped branching pattern. Having a fallback of an F27 branch makes sense for those cases until we're ready to, at every kind of reach of the community, move into that world. EOLs become really interesting because right now when we branch for a new release, every branch in a release has the same EOL for it. It's about 2 years for Fedora when that no longer becomes supported. But if we break out the components to have their own EOLs that aren't associated with the release, we need a way to define an EOL for that component and then propagate the EOLs of multiple components through to the modules that depend on them. Right, the thought here in Fedora is that we'll use PackageDB as the place to both request new branches as well as and we'll have to modify it, to define new EOLs that correspond with those packages. So when I say I'm going to create a new Python request 2.12 branch, I may say this has an EOL of only 6 months. And any module that depends on that particular stream of Python requests therefore has at maximum an EOL of its own of only 6 months. And that is interesting, right? Our tooling that goes through and figures out when we need to retire branches currently assumes that branches are retired en masse when that release of the distribution is retired. But now we'll need per component tools that go through and figure out when EOLs have expired and retirement needs to take place. Yet another question comes up is what's the economic force in Fedora that goes through to create new branch requests? Currently, that's done for us automatically at new release time when there's a mass branching for F27 or for F26. With branches like this, it'll come up, I think, on a use case basis. Right? If there's a module that we decide that we want to ship, a Postgres module that needs a particular dependency on a particular stream, if a suitable stream isn't found, then we'll need a mechanism in PackageDB to request that new branch. What will happen to components that don't receive any new branch requests? Right? It's an interesting way to identify components in the distribution that have existed only because they continue to be there. But if no modules are requesting new branches for them and all of the other, branches and their EOLs have expired at that point in time, then there's no reason to keep them around anymore. There's no force to kind of keep their branches alive. So that is there. Lots to think about, lots to do. If there's any questions, I'd be glad to take them. I see Tim in the back.
So when you're talking about that branching scheme, how does that affect upstreams that either don't do releases or don't use semantic versioning?
So the names that I gave for the branches are like 2.12 and other. Oh, I need to repeat the question. Now I forget it. Right. How do we deal with upstreams that either don't do releases or don't have semantic versioning? There's some projects that use a year-based release number, and they just do like a timestamp release, and they do one every day, for instance. And so my response would be that the examples that I gave were numeric semantic versioning ones, but don't read too much into the name of the branch. The actual metadata associated with what the branch is, what its EOL will be, what to expect from changes in it would actually be defined in metadata in PackageDB. Yeah, it depends on your use cases for them, right? So how do you want to end up distributing it? A nice way to do it might be to create two branches off the bat, one called super stable and one called kinda stable. And like those are arbitrary names that Tim made up, but that's fine. Any module that wants to consume those streams just needs to know those branch names from you and depend on them, and you decide the EOLs on how long you're willing to support that in Fedora. Right? We would have different considerations for how long we're willing to support a maintenance branch of something internally, but we have that flexibility now where we didn't before. Adam?
Can you skip back to the slide where you have the CI workflow, kind of a high-level diagram that had the policy engine in it?
Yes.
So my thought, and it's quite a brand new thought, it's very newly born. What if ResultsDB had an arrow going the other way into the policy engine, so that when it gets a message, and not ResultsDB, the actual test, the CI infrastructure, which isn't up there. But the CI infrastructure is going to respond to various kinds of inputs, right? And one thing I've been thinking is, depending on the input it gets, it's going to want to do different tests. So do we have the same policy engine or a different policy engine where we define that this kind of event we run these tests?
Yeah.
Is that what we need to think about as well?
That's what we need to think about. Well, I would definitely call it a different kind of service, and it sounds like a corollary to like a TCMS
Something like that.
kind of thing, you know? Yeah. So yes to that. When discussing this work in other contexts, the idea came up to use Policy Engine to drive that same kind of work, because if we know that in this context, and this context, the union of that is these tests are going to be needed, well then really those are the only tests that need to be run. One of the things that we were... You could run, in reverse. But there's a downside to that, in that one of the things that we thought would be a bright spot in this architecture is that you could add new tests to be run on every change that were superfluous, that were experimental, without breaking anything. Right now with the errata tool internally, if you want to add a new test to it, you got to really be sure what you're doing, because you're tying it right to the big behemoth. Yeah, it'd be nice to run tests that are silly. Yeah, and you can learn from them and experiment. And, in front, and then Pingu. When can we expect this in Fedora and RHEL Production? Yes, so the answer is different depending on which part of each of the three themes. So on the measurements thing, we won't be doing any of that in Fedora just for lack of time and resources. On the CI stuff, you will see a portion of that in Fedora first and another portion of that internally first. And so the portion you'll see in Fedora first, before F27, is the pull request based flow with an elementary loop. It's not, let's move down the slide. I'm going to refer to it. In this one, you'll see this in Fedora without this part really soon, which is a pull request interface directly querying ResultsDB, which means it won't be as flexible. It'll mean that all tests matter instead of being smart about which ones do. So the MVP, the minimum viable product, is to do this in Fedora without the policy engine, and we'll insert that afterwards. The part that you'll see internally first is actually this part, but without this and without this. It's about decoupling things that are sistered to the errata tool right now that make it really slow and cumbersome to develop. And so we want to break those things apart, things like RPM diff and the other tools that get run there right now. Does that answer the question? Yes. Great. Pingu?
What is on the, so to come back on the Git repo master branches questions, what is in master?
That's a good question. I keep it there because I can't imagine a world without rawhide. Yeah, you could say that master is the only branch that has no EOL.
But which version goes there?
Yeah, I don't know. Yeah, maybe we just kill it. Really. Yeah, whatever's latest. Yeah.
And then you basically, which means that you basically create the 2.12 branch only when the 2.13 is out.
Right, yeah. Or unless nobody wants 2.12, then 2.12 never gets created. But yeah. And something would have to have declared a dependency on master beforehand and then absorbed a change that broke them. And then that meant that they needed to request an old support branch on a new line.
Which breaks the automation ID, which breaks the automation ID, because then you can't, when you rebuild something because there was a new version, you can't rebuild the same module because you need to actually go and change the metadata of the module itself.
Oh, I'm doing a thing to repeat the question into the microphone. The question was what to do with the master branch. in this diagram.
So if you only create the 2.13 branch if you only create the 2.12 when the 2.13 is out, it means that you're breaking every single module that is depending on this specific version.
Yes.
It's not necessary to always have to. You probably only have to really create a new branch if there's change. I mean, if there's not a breaking change, then you just have the 3.x branch.
Yeah. Yeah, Stephen's point was that you only have to create a new branch if there's a breaking change. But what constitutes a breaking change also gets determined by the confines of what you declared the branch would support. Right? You might have a branch that you say is your wild, almost upstream branch that's special for your component. And if there might be other things that expect to depend on something that produces breaking changes like that. It's not necessarily a bad thing. I'll move. Other questions? Tomas in the back. You'll be next, Mix. Yes.
So you were talking about auto-waivers, right?
Yes.
My question to that is why would you run such a test which you waive in the end, anyway?
The question is, with auto waivers, why would you run any test that you waive automatically in the end, anyways? And part of it is. Oh, repeat the question. Did I not do it? I did, didn't I? I did. I did it. Repeat it again. The question was, why have auto waivers? If you have auto waivers, why run the test in the first place if you have somewhere encoded the knowledge that you're going to automatically waive it no matter what the result is? And the answer is historical baggage, and that we have a lot of things that already exist in our infrastructure, tests that get run anyways today, and we don't necessarily have control over who decides when they get run and how. And we also have defined today a lot of auto waiver rules already in place. So it's about making sure we can retain backwards compatibility and actually make this change in production and still be able to do what we did yesterday while at the same time making ourselves flexible enough for tomorrow.
Auto waiver might also have rules. It might be auto waive when you build this module, but not when you.
Exactly, yeah, and that's part of our requirements document for waiver DB. The point was we may need to be, we'll certainly need to be aware of waiving things for certain products or for certain modules, but not for other products and other modules, which is the case in the existing auto waiving rules that we'll need to make sure we get retained. Because you spoke earlier, Tim, I'm going to go to Misk on this side of the room.
So, it's not really into your presentation, but did you shave your bar because you are walking now or something like that?
The question was, did I shave my beard because now I'm working on enterprise products? And the real answer is I shave my beard because when it gets cold, there's not very much sunlight, and I just need to shake things up. So, yes. With the
Team has own Jenkins, so the cloud of Jenkins masters and slaves. Did you force teams to provide an interface to gather intelligence on the tests, etc.? Or have you, let's say, provided them some bonuses? What was the study?
some bonuses.
I don't know, maybe somehow it improved the workflow or something. How have you made them provide interface to feed the result DB, etc.?
Gotcha. If I repeat the question and tell me if I got it right, is how do we convince QE teams with their existing workflows to provide the data that we would use to populate results DB? Convince them or force them. How did we do one of those two things? And the answer is that we did neither, is that we identified initiatives that were already ongoing to publish some data from those different Jenkins masters. And then we worked with those teams to modify the format of that message enough so it would be suitable for their needs as well as ours. So the most expensive part of that project would be going through all of the hundreds of Jenkins masters and one by one getting the team to enable publishing. So it's about latching on to things that already existed. Like I say, we currently have data from platform for that, and we don't yet have the data, but we have a plan and agreement to get data for all products right now with ShipShift is the initiative. Yes?
Is there a way to promote scratch builds through this pipeline so that they can go out officially?
I plead the 5th, is that the thing you say? Promoting scratch builds. Oh, repeat the question. Is there a way to promote scratch builds in this pipeline so they can make it through the system? And to be honest, that's one of the major problems that we have with NVR uniqueness in Koji and Brew in this situation. And promoting scratch builds is one of 7 options that we've identified to solve that problem, but we haven't landed on which solution we're going to use for that. One of the competing ideas is to use namespaces in Brew, which is a feature that doesn't exist today but is in the Koji 2.0 docs, to allow a null namespace where we could rebuild the same NVR multiple times, but it wouldn't conflict with previous versions of that same NVR. So it is a problem. Steph?
Where are the tests stored? Are they associated with a package, with a module, both? How are they versioned along with the software itself?
Yes. The question is, where are the tests stored? Are they associated with a package, with a module, with both? And are they versioned with the software? Right. In the case in both Fedora as well as internally, they're stored in dist-git. Not in the same repo where the software is stored, but they're stored in a repo of the same name under a different directory. So we've had discussions about this in the past, whether it's acceptable to have tests that aren't in the same repo, and it may be resolved so that they wind up in the same repo, but today they're in different repos. To the second question, we have namespaces available and capacity to execute tests that are associated both with the RPM or with the module. And to the fourth question, yes, they are versioned along with those things. In Fedora, the branching structure for those test repos corresponds exactly to the branching structure for the RPM and modules repos, as well as the ACLs. So anyone who has access to modify the software also, by default, has access to modify the tests. Amanda? Yeah. So the module integration testing gets kind of to that point where, oh yeah, I gotta do it. What's the expectation for module integration and module testing? And I think that it's the same that we would have on RPM and RPM integration today, even though we don't have a good backstory for how we're actually doing that testing of combinations of RPMs. So in order to test a module that declares dependencies on other modules, we would define tests in this dist-git repo that corresponds with that module to test that module. And by exercising the API of that module, it's assumed we would be testing the other modules that depend on it as well. But this... Yes, exactly. Yeah, and on streams of modules as well. In my diagram, I only showed a module depending on RPMs. Modules can also depend on other modules. Yes?
You said that in every package and then also every module can define their own EOL pretty much any way they like for each branch. Then how are we going to manage user expectations with such a model? I mean, now the users know that they have Fedora released it supported until the Fedora N plus 2 plus 1 month, so usually about 13 months. But now they have packages that the maintainer says this branch is supported only for 2 weeks and the other one is supported for 10 years and they don't know what to expect.
Right. No, that's a good point. The question is, how are we going to deal with user expectations if the release of Fedora previously had a unified EOL of 13 months, but the components that go into it have willy-nilly branches with EOLs of their own making? Is that a correct rephrasing? Yeah. So my response would be that we're going to model the core Fedora release. Core is a loaded word with Fedora, right? But like the base release of Fedora, the center of the offering, Fedora server, right, would be modeled as a module that depends on other modules, which depend on the RPMs going into them. And for any module, its EOL would be derived. Let's say it would be derived from the floor or the minimum of all the EOLs that go into it. So if we go to create Fedora 29, and we look at all the RPM branches that are going into it, and one of them is going to go EOL 3 days after release, the tooling will have to alert and say, well, Fedora 29, when we release it, is going to go EOL 3 days after we release it. And that's the prompt. Yeah, awesome, work's done. That's the prompt to go to that component and say to the maintainer, can you create a new branch with another 13 months of EOL? And let's say there are community members like, listen, I don't have time, to support a branch of this for that long. Then we need someone from the community to be able to step in and create that branch and support it to support the release.
That means that for the whole of the packages in Fedora, there will no longer be such a guarantee, so that's much less user-friendly than what we have now.
Well,
Because they now have 10,000 packages, and no matter what package you install, you can expect to get updates for 13 months. Now, with your proposal, the ones that are in one of your core modules, they will have these guarantees, but what about the 10,000 or 15,000 other packages that are not in one of those modules?
The point is that there'll be this disconnect between things that are in the core and things that are on the outside, and I just say that would be the case, and it's a change in user experience for this, and I think it maps to the rings discussions that's been going on for years now. But
For the users, much worse. It makes Fedora useless for the users. They don't know, they have tons of packages, but they don't know how long they will be supported. They can just display, I don't know.
yeah, so for the room and for the recording, the point is that the user experience will be much worse, and I think that's a conversation to keep having outside the room. We're out of time for now to have any more discussion here. So, thank you.
Well done, RHEL. So it's like you were really busy, like past month. So I had no idea you did so much work stuff on the infrastructure. Wow, I'm really amazed. We can do a lot. There's a lot more to do. The branching stuff is not something that is ready to land yet. We still have to write that in the package sheet. So, how long are you going now?
All next week. I'm leaving on Thursday night.
Okay. So, see you later.
I'll see you in the office. Yeah.
Just head off. That's an emergency. I saw that person. So.
How are you?
Good. You? Nice. Nice job. Thank you. Except for repeating the questions. Oh, yeah. That's impossible.